Hello, it's Miss Moorfield, and we're going to continue talking about coordinate graphs, but we're going to add another skill to them. So you'll see I have a coordinate graph below. My origin is 0. Of course, we know that this is my vertical axis, or my y-axis, and this is my horizontal axis, or my x-axis. I'm counting up by 1 still for each line, but you'll notice that I've told you that each square, or each line over, is 1 mile, because what I've put on my coordinate graph is the locations of 3 different friends' houses. So this is where Bill lives in relationship to Manuel and relationship to Tom. So kind of like I've made a map on my graph of their 3 homes. So what I'm going to look at is then how can I figure out how far away they live from each other? How many miles away is Bill from Manuel? How many miles away is Bill from Tom? So what we're going to do to find that out is use our coordinate pairs, because those are our directions for how to get to one point, so I can use those also as directions on how to get from one to the other. So if you look at the first question, asks from Bill to Manuel. So Bill is here. He is at 2, 3, or he is over 2 miles and up 3 miles. And Manuel is here at 8, 3. He's over 8 miles and up 3 miles. So what they should first notice is that they are both at the vertical location of 3 miles. So they are both 3 miles up from our origin, which means they're on the same street, right? If they're both 3 miles up, then they're both on the same street. But how far down the street is Manuel from Bill? Well, in order to figure that out, I want to know what's the distance in their horizontal coordinates. I know their vertical coordinates are the same, so how far away are they horizontally? Well, Bill is at 2 and Manuel is 8. That's simple subtraction. How far away is 2 from 8? Well, all I have to do is say 8 minus 2, which we know equals 6, and I know that Manuel is 6 miles down the same road that Bill is, or 6 miles away from Bill. So once I recognize if one of the coordinates is the same, finding the distance between the two of them is very simple. So looking at number 2, now we're looking at Bill and Tom's all the way up here. But again, I'm going to look at their coordinate pairs. I don't see a 3. Tom obviously isn't on the 3 because he is much, much higher than Bill and Manuel is. But what I do notice this time is that he's on the same horizontal point as Bill is. They are both 2 miles horizontally, which means they also share a street. So think of it as if there's an intersection, right? 2 perpendicular lines. If Bill's in the middle of the intersection, Manuel is down this street and Tom is up this street. So Tom and Bill are both 2 miles horizontally or over from our origin, but are vastly different on their vertical directions. Bill is only 3 miles vertically from our origin, or 3 miles up from our origin, and Tom is 8 miles up from our origin. So to find the distance between the two of them, I'm not going to look at my horizontal direction this time, but instead I'm going to look at my vertical direction. So the distance between Bill and Tom is the distance between 8 and 3, which of course I know is 5. So Bill is 5 miles away from Tom on that same street. So again, if we come back to my little drawing over here, if this represents Bill, then Tom is 5 miles up and Manuel is 6 miles over from the same intersection. So our coordinate graph can give us a lot of information in terms of directions to one point, but also the distance between points, or the relationship between various points on the same coordinate graph. So looking at our next example, this time I tell you that each square only equals 1 foot. So maybe this is distance between people in a room. This is a diagram of showing you where everyone's standing or sitting in a classroom, and I'm comparing Susie and Sherry and Winnie, and I want to know the distance between Sherry and Winnie. And I know that based on my question mark is obviously signifying that's what I want to solve, but I'm not given either of their coordinate pairs. I'm told that Susie is at 3, 4, but she's irrelevant to my question, so actually I'm just going to ignore Susie for now. To compare Sherry and Winnie, I do notice that they share the same horizontal point. They both are over 7, so I know that 7 is the first number in both their coordinate pairs, which is why they can be stacked like that, one on top of the other, because they're both at 7 feet over from the origin. But what I need to figure out is what is their vertical point? What is their vertical coordinate or their y-axis? Well, Winnie is 2 miles up, so I know she's at 7 comma 2, and Sherry is 8 miles up, so I know she's at 7 comma 8. So the distance between Winnie and Sherry, since I know they're both over 7 feet, I need to compare now their vertical distance. 8 feet compared to 2 feet. Well, now I can figure out that my question mark is a difference of 6 feet. Sherry is 6 feet away from Winnie. So again, using those coordinate pairs to decipher the distance or to find the distance between two different people or points. So what I want you to do for homework tonight is find the distance from Bob to Billy and also find the distance from Joe to Billy. Notice I have not given you your coordinate pairs, so you'll have to find those first. I did tell you that each square is 1 kilometer, so your distance should be labeled in kilometers. Please post your answer to number 1 and number 2, as well as any questions you have on Edmodo tonight, and we will talk further in class tomorrow.